Good morning all. In this class, we'll discuss about how to calculate length of path of contact for gear pair. Okay. So as we discuss this KL is known as length of path of contact, whereas in KP is path of approach and PL will be the path of process for this gear pair. So to get that arrangement, contact between pair of inward gear, which is beginning at K and it will end at L. So this is the simple arrangement which we are talking about, where we have this KP and PL distance. Okay. This Mn is the common normal line which we are drawing, which is passing through the point of contact P. Okay. So this is also tangent to the base circle, and we are discussing this how to find out approach and traces. So what we have, this small r is piece circle radius for pinion, capital R piece circle radius for gear, the small ra addendum radius for pinion, capital Ra addendum radius for gear. Then we have phi pressure angle for this pinion and gear. Okay, and phi second phi is nothing but we are talking about the pressure angle of that tooth surface. Okay, now to calculate these values, okay, so what we are doing, we are taking this Ra addendum radius, which is O1L. So Ra is defined by distance O1L for pinion, and this capital Ra for gear is defined by distance O2K. Okay, so this is the P circle radius O1L and O2K. Then this O1P is the O1L and O2K are nothing but addendum radius for this pinion and gear. And this O1P and O2P are nothing but P circle radius for pinion and gear. So we are talking about small r, the distance is O1P, and capital R is distance is O2P. Okay. Now if you consider the triangle O1MP, so take triangle O1MP. Okay. So what we have, this O1M is nothing but R cos phi. This distance is R cos phi. Similarly, if you take triangle O2NP, to take triangle O2 and P, then what we have, this O2 and this distance O2N is nothing but R cos phi. Okay, so if you take a triangle O2KN, then what we have, this Kn distance, we can write Kn distance is equal to O2K square. Okay, this O2K square, okay, minus O2N square. This Kn square is equal to O2K square minus O2N square. Similarly, if you take this part, now what is O2K? This is Ra. What is O2N? R cos phi. Okay, so simply you are putting the value of addendum radius and this O2N distance to get the Kn value. Okay, so this Kn is given by under root of Ra square minus R square cos square phi. So we are defining this Kn in terms of addendum radius of gear and P circle radius of gear. Similarly, if you take Pn part, okay, second part is Pn. So Pn is nothing but again O2P sin pi. So this Pn part is O2P sin pi, which is R sin phi. Okay, that is the value of Pn. Okay, now next we can write length of path of contact is equal to Kp is equal to Kn minus Pn. So what is Kn? Okay, Kn already we have calculated R square minus R square cos square phi. What is Pn? R sin phi. So just put the value of Kn and Pn. So we'll get value of Kp. That is path of approach. Similarly, if you take a triangle O1ML, okay, this is O1ML distance, then we have O2L square minus O1M square. That is under root of Ra square minus R square cos square phi. So again, we can put the value of MP. MP is O1P sin phi. Okay, that is R sin phi. Okay, so we can write PL distance. This PL distance is ML distance minus MP distance. What is ML? Already we have calculated ML in terms of addendum radius of pinion and P circle radius of pinion. R square minus R square cos square phi minus outside the square bracket R sin phi. So we can calculate path of contact and total length of path of contact by considering this Kp and PL distance, that is path of approach and path of process, which will be under root of R square minus R square cos square phi plus under root of R square minus R square cos square phi minus R plus R sin phi. So in this way, we can find out the path of contact distance, that is this KL distance. So this distance is KL, which will be Kp plus PL, approach plus traces. And we have this O1 point at this location, that is central gear. We are taking help of R, P circle radius for pinion, capital R, P circle radius for that gear, Ra, addendum radius for pinion, then this Ra, addendum radius for gear, small Ra, addendum radius of pinion, to calculate the value of approach and traces. Okay, so in this way we can find out the data related to path of approach and path of traces for simple gear of wheel. Okay. Then next, we have arc of contact. Now, once we have the path of contact, then we can define the arc of contact, that is path traced by the point on the piece circle from beginning to end of the engagement. So this arc of contact we can define with the help of EPH. Okay, the distance EPH, with the help of EPH or GPH, we can define the arc of contact. So this is the moment of this arc of contact, simple GPH. RPH is called as arc of recess, okay, and GP is known as arc of approach. So this is the arc, that is distance traveled during the engagement, distance traveled during the disengagement, approach and recess. So this arc of contact is given by path of approach upon cos phi, Kp upon cos phi, and arc of recess we can calculate by path of recess upon cos phi, PL upon cos phi. So total length of arc of contact is given by length of path of contact upon cos phi. Okay. Then next part we have contact ratio. So basically we can calculate contact ratio, the ratio between the number of pairs which are in contact during motion transmission. So that ratio we can calculate by considering length of arc of contact upon circular pitch. Okay. So length of arc of contact is, already we have discussed how to calculate length of arc of contact with the help of path of contact. Then just divide by circular pitch PC, that is pi into module, you'll get contact ratio. Okay. So normally this contact ratio is 1 point. Suppose if this ratio is more than 1.5, then we are taking as a 2. That ratio is 1 point less than 1.5, then we are taking the contact ratio for gear is 1. Okay. So in this way we can determine the contact ratio for a simple pair of engagement for pinion and gear. Okay. Now just we'll discuss one example, and by which we can understand how to find out this path of contact for a simple pinion and gear. Okay. So next class we'll discuss this part of calculations, how to define this contact ratio for single pair of gear. Okay.